C++ Builder is a multi-device development solution for targeting desktops, laptops, slates, and tablets, including Surface Pro. And coming in 2013, iOS and Android. Embarcadero C++ Builder XE3 is the only way to create native applications for 32-bit and 64-bit Windows, including Windows 8 and Mac OS X, including Mountain Lion, with a single C++ code base. C++ Builder XE3 delivers the best of both worlds, a highly compliant C++ 11 64-bit Windows toolchain with an agile development solution. Now you can use the latest C++ features and libraries while you speed your development process with C++ Builder's agile visual development environment. 64-bit C++ Builder for Windows includes a new C++ compiler that supports the C++ 2011 language standard. You can use VCL and FireMonkey applications in 64-bit Windows, and we have the latest versions of Dinkomware Standard Library, version 5.3, Boost Libraries, version 1.50, and a highly optimized code generator in our compiler. The new compiler gives you the best of all worlds, the visual rapid application development environment, support for all the latest language standards, compatibility with Borland C++ and the standard libraries, and the ability to generate Intel code for 64-bit Windows, and in the future for ARM processors for multiple devices. You can compile your VCL and FireMonkey applications using the new 64-bit compiler, and continue to use your 32-bit VCL and FireMonkey applications as well. The 64-bit compiler has full support for the C++ 11 language and library enhancements in the latest standard. As I mentioned, we include the Dinkomware Standard C++ Library, version 5.30 for the C++ 64-bit compiler, which gives you the standard template library, the standard C library, and the standard C library headers. Some of the new C++ features began their life in the Boost libraries. We ship two versions of Boost, for 64-bit C++, the 1.50 version, and for 32-bit C++, the 1.39 version. Now, when working in 32-bit and 64-bit C++, you'll have to pay attention to a few things in your applications. Size_t is defined as an unsigned integral type. In 32-bit and 64-bit Windows, this is the same size as a pointer. _win32 is defined for Win64, and _win64 is defined only for Win64 targets. So you can use both of those defines in your applications to deal with differences between the languages and the platforms. Now, when you're doing Windows programming in 64-bit, you're going to use a familiar Windows API. The Windows API calls must be 64-bit versions. Try blocks are supported in 64-bit applications. A 64-bit Windows application can use 32-bit Windows type libraries. You can't mix 32-bit and 64-bit code in the same process. If you have DLLs, components, and libraries and packages, you need to have 32-bit versions for design time use and 64-bit versions to compile into your runtime applications. Of course, 64-bit Windows compilation is needed for operating system extensions and shell extensions on Win64. And also pay attention to the size of lresult, wparam, and lparam. The BCC 64-bit compiler is based on the Clang compiler front end. It has different compiler options. It's more compliant with the C++ language standard than BCC 32. There are also new and more specific warnings that you'll get in using BCC 64. BCC 64 supports three different header source paths. -I system is used for system headers, -I for headers provided by third parties, and -I quote for your own source files and headers. Precompiled headers work a little differently in 64-bit compiler. Each 64-bit Windows C++ project can have only one precompiled header. A default precompiled header is generated for each new C++ project for any platform. Object and library file formats are different. BCC 32 uses OMF in the .obj and .lib files. BCC 64 uses ELF format in .o and .a files. When you migrate a 32-bit Windows application to 64-bit Windows, you must change references to .lib and .obj to be .a and .o respectively. You can use Unicode in literal strings and file names, but Unicode is not allowed in identifiers in BCC 64. If you want to do inline assembler, BCC 32 style inline assembler is not supported. Functions written entirely in assembler can be used as long as they're linked into your program and built with a separate assembler. Clang does support inline assembler, but it uses the line-by-line AT&T syntax, not the more familiar block of Intel syntax. If you have existing BCC 32-bit projects, To upgrade them, you want to pay attention to object and library file formats. Again, as I mentioned, BCC32 uses OBJ and lib files. BCC64 uses the ELF format in .o and .a files. So where possible, remove your object and library file extensions. And when necessary, if you're using a custom build script, the extension must be changed or made conditional with version detection. Applications that use the Windows API must explicitly contain #include windows.h. In BCC32, including windows.h was not required, but BCC64 does require it to be defined. So let's take a look at the IDE and some demos and how you could build 64-bit Windows applications. Here we are in the IDE, so we can just say File, New, VCL, Form Application, C++ Builder, and we'll build the first sample application. Just put an edit box, and we'll put a list box and a button, and we'll create the event handler to add items to the list box, and we'll just take the text property from the edit box and add in the list box. We'll hit Run to create a 32-bit Windows. Notice the target platform is set to 32-bit Windows. We can put in text, and it's working. We can go and add to the target platform 64-bit Windows for C++. It becomes activated. Let's compile and run the application. And now we have a 64-bit version of the application, and it runs just like the 32-bit version. The way we can tell that it's a 64-bit application is bring up the Windows Task Manager, look at Project 1, and notice project1.exe does not have *32. It's a 64-bit Windows application. 32-bit Windows applications have *32 after the name of the application. We can also take an existing FireMonkey application that's written in C++, and we can run it on 32-bit Windows. We can also add a target platform 64-bit Windows and simply recompile and run it. And now we have a 64-bit version of this FireFlow application, which allows us to flip through or flow through different images or in a folder on our computer. If we look at the Task Manager, FireFlow is a 64-bit application running under Windows. Here's another example that allocates 1 megabyte memory blocks under Windows. And so on 32-bit Windows, we can run it, and it'll give us just something under 2 before it runs out of memory on the stack. We'll switch this to 64-bit Windows. And again, it's just C++ code that's going to allocate storage at 1 megabyte at a time until it runs out of memory. It's got a try block and a catch, and it will display the exception. And when it's done, free up the memory. So let's run this example in 64-bit Windows. And notice now it will count up to 4 gigabytes until it finishes, and then it frees up the memory, and it's done. One last example is, in this case, a VCL 64-bit application that uses new keywords in the C++ language. The first one here, it's using the auto keyword to iterate through an array of numbers. And it uses a lambda expression to sort the numbers into the second list box. So let's run this example. Since the auto variable and lambdas are part of the C++11 language, only available in the 64-bit C++ Builder compiler, we'll only be able to compile and run this application on 64-bit Windows. We'll generate the numbers, and then we'll sort them. This is just a quick example of using some of the new parts of the C++ 2011 language in the 64-bit compiler. So that was just a quick preview of the C++ Builder XE3 64-bit compiler in action, building VCL and FireMonkey applications that run on 32-bit and 64-bit Windows. For more information, go to the C++ Builder homepage that's listed at the bottom of the screen.